So now we are going to make estimate population proportion, but now we're actually going to do it based off of an actual work problem. So a survey is given at Barcelona Community College about the quality of French fries at the city cafeteria. From 300 students who surveyed, 200 agree that the fries are the best in town. So construct a 90% confidence level interval, should I say, to estimate the population proportion. So here, we're given 300 students that were surveyed. So we're going to let that be the sample size. So we're going to say n is equal to 300. And out of those 300, the random variable here specifically is how many students actually agree that these French fries are the best. And here, when we look at the amount of students who actually agreed to that was 200. So we're going to say x is equal to 200. And construct the confidence level. So we say our confidence level is 90%. So once again, we have our n, our x, and our CL. So we said p hat is x over n, which implies this is 200 divided by 300, which is 2 over 3, which is 0.67. But we'll just keep it as 0.67. Q hat we said was 1 minus p hat, which is 1 minus 0.67, which is approximately 0.33. So now we have this. Now we want to construct our confidence level. For our confidence level, we need alpha is 1 minus CL. So alpha is 1 minus 0.90. So alpha is 0.10. But we need to divide this by 2. 0.10 divided by 2 is 0.05. So now we have our confidence level interval already. So we know what p hat is. We know p hat is 0.67. So the only thing left over is to find what is E. So we had said E is Z of alpha divided by 2 times the square root of p hat q hat over n. So here we need to find what is Z of alpha over 2. But since we know already Z of alpha over 2 is 0.05, so the last thing what we want to do is we want to be able to construct, find the actual Z score for that. So once again, if you guys don't have a table at home or in your book, once again, I would recommend for you guys to just look up San Jose State University and just put Z-score table. And 0.05, so in case you guys are wondering how that table looks like, it's something like this, right? Just go to San Jose State, SJSU, and then just put Z-score table and it should come up. So 0.05. Or in this case, you guys could 0.95. So 1.6, 4, and 5. So here we're going to be at Z is 1.645. So then here we know this value is 1.645 times the square root of p hat, but we said p hat was 0.67. We said q hat was 0.33. Divide that by 300. So 0.67 times 0.33, let's see what we get. 0.2211 over 300. So 0.2211 divided by 300 is 0.123737. Take the square root of that answer. Is 0.024. And so now we multiply that times 1.645, and our answer is 0.044658. So we're gonna now simplify this to 3 decimal places. So here, 1, 2, 3. Get to this guy, since that's bigger than 5, that's gonna go up. So E is 0.045. So now I get to close this guy up a little bit. So now I could go up here and put 0.05. So now I subtract this. .67 minus 0.045. So this is 0.625 less than P less than 0.715. So this is our confidence interval. So we could say, we can conclude we are 90% confident that the true population proportion is within 0.625 to 0.715. And with that, this is all we need. So we just need to know what n is, what x is, and what's the confidence level. Write down the formulas, just break it down step at a time, and then just put it into your confidence interval formula, get the answers, and we're done. Okay? Thank you.